guys, welcome back to my YouTube channel. So for today's episode of our Digital Electronics 2 lecture, we will be having our summative assessment 1 for our final period, which is an application of analog to digital converter or ADC, which will enable us to create a program that is applicable to our present life. So this is entitled LED Light Display Indicator of Home Electrical Fan, which is our typical electric fan at homes using Pickit3 and PIC16F18875 microcontroller. So this is an ADC application submitted for our summative assessment 1 finals for our Digital Electronics 2, submitted by yours truly, Casabuena, Rica, from ECE31, and submitted to Engr.Emmanuel Longares, our Digital Electronics 2 instructor, for this month of June. So now, to give you a glimpse of our summative assessment, which is our ADC application, we have here our objectives, which is first, to create a paper that depicts the logic of the program code on our Mplab software, which is the paper that I'm presenting to you right now. Second is to create an Mplab source code that can be used for the application of the analog to digital ADC and be able to build it using our software. And third is to use the Pickit3 with the Mplab and electronic components to test the code and perform the application in the actual circuit on breadboard. So for our equipments and components, we will be using the long IC, okay, the PIC16F18875. Next one is our 220 to 1000 ohm resistor, okay. It depends on how many LEDs will you use for the experiment. For this experiment, I will be using 5 LEDs. And then we will be needing a 10 kilo ohm rating potentiometer, which will serve as the giver of our analog input, okay. And next one is 5 LED. It could be color of your choice, okay. And next one is our breadboard, connected wires, Pickit3 or 4, and of course our power supply. So to explain the logic behind our code or behind our ADC application, we will be applying the principle on our electric fan. So if you turn the knob, as you can see here, if you turn the knob, now, as you can see, if you turn the knob of your electric fan at home, you can see numbers, okay? The level of the speed of our motor, which is 0, 1, 2, 3, 4, and 5, okay? Typically, it's 1, 2, 3, but for this application, for complexity, okay, and for the comprehensiveness of our application, we will be using 1 to 5 as our scale for our motor speed, okay? So for our electric fan, instead of just indicating numbers for the speed of our motors, we will be using light or LED indicators to indicate the level or the speed of the motor, okay, which we will be considering 1, 2, 3, 4, 5. So this is the same with our control knob, which we can see on our refrigerator, okay, our appliances, which is like this one, which will indicate warmer or cooler levels, okay. But for the electric fan, we are thinking that this is essential because, let's say for example, our room is dark and we need to adjust the speed of our electric fan motor to adjust the temperature of the room. It will be essential that we have light indicators to indicate the level of the speed of the motor even though it's dark. So this provides convenience to our homes, okay, which is the goal of being an electronics engineer. So that's the logic behind our application for ADC. So now we will be proceeding with our Mplab program. So to start with our Mplab software, we will be just following the experiment number 5 or our analog to digital converter, which is the application that can be seen on our microchip website, which I be providing the link on the description below. So now let's create a standalone project, okay, and then let's click next, and then we will be using PIC16F, okay, 16F18875 IC, which is the long IC, and then let's click next, then let's select the compiler, and then let's click next. Then I will be renaming this somewhat Casabuena. And then let's click finish. So let's wait for it to load up. So let's open our MCC here. So let's just wait for it. So let's just save this one. Okay. And we will be recreating the settings that we use on our experiment number 5, which you can check the link on the description below of our YouTube channel. Then from our pin manager grid view, let's select the right package, which is the PDI40 package. And we will be adding here from our device resources the ADCC, which will allow us to have an analog to digital converter. So let's add this one. Okay, so let's add this. Okay, as you can see, it's already on our peripherals here. And then after that, let's go to our pin manager here. And then let's select our input. So our analog input will be on our ANX. Okay, it's up to you where you would assign it. So for our ANX, I will be assigning RA0. Okay, so it will not be messy for me to create our summative assessment. So it will be our input. Okay, and my output will be 5 LEDs. Okay, 5 LEDs. So I will be putting it in our GPI0 output. So it will be RA1, okay, RA2, 3, 4, and 5. So those will be the 5 LEDs. That will be our LED indicator. Okay, and after that, we will go to our pin module and let's rename this one. So let's rename this, okay, Potent Analog, and then our RA1 will be LED1. So let's copy this one and then LED2. And then this one will be LED3, then LED4, and LED5, okay? And we should make sure that this LEDs here will be output, okay? So just to make it short, you just have to rename this button, okay, for our code. So it should be shorter than the previous name. Then we will be selecting analog because it will be our analog input. Then after this one, we will be going to our system module, okay, where we will be editing our settings. So again, our settings will be, so our setting will be HFI NTOC, then 4 megahertz, then low voltage programming should be enabled and clock divider is 4. Then let's go to our ADCC, okay, and let's make sure that our settings are correct. So I will be selecting clock source, okay, it will be this one, FOSC or analog to digital conversion clock source, then clock should be FOSC divided by 2, then our acquisition count should be 0, then result alignment should be right, then VDD, DSS, and disabled. And after this one, after making sure that all of these are correct, then we will be clicking generate to generate our code. So let's just wait for it. So you can see generation complete. So now we will be creating our source code. So now, explaining our code, we first set our ADCC to be initialized, okay? So we can use it properly in our source code. The next one, we copied this ADCC underscore get single conversion to pull out our ADCC function for our source code, which is to convert our analog input to a digital signal, okay? So for our 5 LEDs, we considered the rating of the potentiometer, which is 90%, almost 100%, wherein if the rating of the potentiometer is greater than the 900, okay, or it is almost on its maximum value, meaning the resistance is so high, commonly speaking, okay, so logically, our LEDs, all of the 5 LEDs will be set low, meaning the resistance on the electric fan circuit is so high that all of the LEDs are not lit, or they're all turned off. While if we will be considering the reading of the potentiometer, as you can see, it is decreasing, okay, up to 400. If we decrease the value of our potentiometer from 900 to 800, as you can see, one LED is set high, meaning our electric fan is at its level 1, okay, meaning it's when you turn the knob, it's on number 1, so it's turned on, but the speed of the motor is not as fast, okay, because the resistance is still on its 80% of the 10 kilo ohm rating of the potentiometer. So only one LED is lit as our level 1 indicator. Then for our next potentiometer rating, which is 700, our LED 1 and our LED 2 will be set high, meaning our electric fan motor speed is at level 2, okay, because the resistance decreases. So the current on the electric fan circuit will flow more, meaning the speed of the motor will increase. So the same logic will apply to the next source code. From 700 to 600, LED 3 will be set high. We are already on our level 3 of the electric fan motor speed. Then for the 500, we are already on the level 4, okay, meaning the speed of the motor is continuously increasing. And for our level 5, all of the LED are set high, meaning the speed of the motor has been maximized, and the electric fan level is on level 5 already, which is its maximized state, okay? So that's our logic behind our source code. So after making sure that our source code is explained already, we will be building our code here. So let's just wait for the notification, which will say build successful, okay? Let's wait for it. As you can see here, it will say build successful. So now we will be connecting our Pickit3 to our Mplab IPE. So now, using our Mplab IPE, we will be connecting our Pickit and we will be uploading our program, okay? So our program's name is someone Casabuena. So let's click OK. Then we will be editing our settings here. So don't forget that our password is microchip, and then our power should be 3.125 to avoid damaging our IC. Then this is okay already. Then let's go to operate, and then let's browse with our program, and then let's go to local disk into files, and then easy 30 and 30 consent, and then digital lab 2, and then someone Casabuena, and then this full production, and this text file here. Then after that, let's click program. Let's just wait for it to say that programming complete. Then after that, we will be constructing our circuit on our breadboard. So as you can see, programming complete. Let's now proceed to constructing our circuit on the actual breadboard. Now, connecting our Pickit3 to our PIC16F18875, you have to remember that this first wire here is for our M control, and then our next wire is for VCC or our VDD. Then for our ground, we have here the third one, which is our BSS on the IC, and then PGD is the fourth pin, and then the fifth pin is PGC, and the arrow here is the MCLR. So just connect it, and we already connected it in our Mplab IPE, and we will be programming our IC. So after programming our IC, let's remove it from our Pickit3, and then we will be constructing our circuit using our breadboard here. Okay, So let's remove our IC from our IC adapter, and then we will be connecting it in our circuit here. So here. So let's connect it properly, taking note of the notch of our IC. So for our circuit, we will be using our potentiometer as our analog input, and then our 5 LEDs here, which will be 3 color red, okay? That will be our indicator for level 1, okay? Level 3 and level 5. So these are the extremities of the level of our electric fan. Then we will be considering level 2 for the green LED, then level 4 for the blue LED. So we will be needing 5 resistors, 360 ohm resistor, which will be connected to our 5 LEDs. So now we will be constructing our circuit. So just rely on the pin configuration shown in our screen to properly construct our circuit. So we will be using connecting wires to connect our LEDs. So for our analog input, we will be considering here a potentiometer, okay? So let's connect a potentiometer here. So after connecting the potentiometer, let's connect a connecting wire to our second pin, okay? Second pin of the IC, the third pin of the IC is for the LED one, so 1, 2, 3. So this is for the first LED, so let's connect it here. Then connect the red LED here, and then 360 ohm resistor to the ground, okay? So let's connect an LED and then a resistor to the ground. So just connect all of the 5 LEDs to our 5 pins. So next will be the green LED for our pin number 4. Okay, pin number 4. So that will be this one. So pin number 4 here. And then this one here. Let's connect our green LED for the level 2. And then resistor, okay, to the ground. And the next one will be our level 3. Okay, let's select here our pin number 5. Okay, pin number 5 of our IC. And then level 3 will be red LED. And then our resistor here. Okay, make sure that all of the connections are correct so that our circuit will be functioning well. So our 4th light or LED will be on our 6th pin of our IC. So 6 pin. So this will be 1, this will be 3, 4, 5, then this one, number 6. So let's connect it here. And then for the 4th light, we will be using a blue LED here. So blue LED, then another resistor. Okay, another resistor. And then for the 5th LED, we will be using our pin number 7. Pin number 7 will be after pin number 6. And then this, okay, this one here. This one here connected here. So for our level 5, we will be using our red LED as our indicator. So let's connect it here properly and then another resistor. Okay. So for our potentiometer, we will be connecting its 2nd terminal to our pin number 2 of our IC. This will serve as our digital, okay, as our analog input. Okay, that will be converted to our digital output. So let's connect the terminal 2 of our potentiometer to our IC's pin number 2. So here, this one, and the first terminal of our potentiometer should be connected to the to the positive terminal of our voltage supply here. And then the third will be on our ground. So let's connect it properly. Okay, make sure that all of the components are connected properly. Okay, let's fix it. Okay, and for the 3rd terminal, let's use a gray wire here. So this one, then this one. Okay, split on the other side, and then this one on our positive terminal. So just to clarify, okay, if we want to turn our knob, okay, to the right, we have to be specific with the terminal of our potentiometer. So since we will be using a typical electric fan in our home, so we will be setting the potentiometer, and when we turn it to the right, then our level or the speed of the electric fan motor will increase, okay, and the LED will light up all, okay, as our knob is turned to the right. But when we turn it to the left, meaning the resistance or the potentiometer reading is decreasing, then the LED will individually be turned off. So with that, our 3rd terminal, okay, the 3rd terminal of the potentiometer should be connected to the VCC, okay, and for our 1st terminal, it should be connected to our negative supply. So after this one, we will be connecting our VDD, okay, which is on the 11th pin. VDD is for the positive terminal. So starting from 7, 8, 9, 10, 11. So this will be for the positive terminal of our voltage supply, and then the VSS should be connected to our negative terminal of our voltage supply. So negative terminal will be here, okay, and on the other side, don't forget the 32nd and the 31st pin. So let me count. 40, 39, 38, 37, 36, 35, 34, 33, 32. So this is the 32nd pin. So the 32nd should be connected to our positive terminal. Okay, positive terminal here. And then VSS should be connected to our ground. Okay, so let's use a gray wire. A gray wire. Okay, so as you can see, this will be the connection of our circuit for our summative assessment 1. Okay, for our summative assessment 1 for the final period. So we have your potentiometer and our 5 LEDs. So now we will be connecting our 5 volts voltage supply. So now, to test our circuit, we connected a 9 volts battery with our power module here to convert our 9 volts to 5 volts, or literally to step down the voltage to avoid the damage of our IC. So now let's turn on our power module. So now we will be adjusting our potentiometer here, just like how we adjust or turn the control knob of our electric fan when we want to adjust our fan speed, okay, to make the air cooler inside our room. So now let's move it to the right. Okay, let's start. Okay, so this indicator here serves as our level 1, meaning the speed of the electric fan motor is just moderate, okay, it's not extremely fast. So for our level 2, which is our green LED here, okay, by the way, the level 1 is the red LED, okay, or our first level. Then for the level 2 or the green LED, okay, for the green LED, this indicates that the resistance of our circuit inside the electric fan is decreasing, okay, meaning the current flow increases, which allows the increase in the speed of our electric fan motor. So that's the level 2, the green LED. Then for our 3rd level, okay, our red LED light up for the 3rd level, meaning the electric fan motor speed is continuously increasing as the potentiometer decreases, okay, as the potentiometer rating decreases. Then for the 4th level, okay, for the 4th level, we use the blue LED indicator, which implies that the speed of the motor is approaching its maximum speed. Then for the maximum speed, we have here the red LED. Okay, so as you can see, the potentiometer already reached its maximum, okay, meaning the resistance is too
little already. That's why the current flow increases, which allows the speed of the motor to be at its maximum, meaning the electric fan is already at its level 5. So that's one of the application of our analog to digital converter using our Pickit3 and using our potentiometer as well as our LEDs. So this is important in our control systems, in our appliances, which can be used in daily applications, just like in our refrigerator, washing machine, our speakers, and our motors. So that's all for today and for our summative assessment 1. Again, my name is Rica, and I hope you learned something from our vlog today. See you!